Hey there, and welcome back to the channel. I'm Brian, and in today's video, you saw it, board 001 is back on the bench. Right now, take a look right up here. You can see that it said failed to init PIC controller. Well, that's a new one for me, and it gets better. So let me show you this. So I put it in my test miner, and it is sitting there. It loads up. You see it says error initializing the board. So what's going on? Now I've gone to 0 chips. Now, so this board has got a lot that needs attention on. We got a weak chip somewhere. We may have a bad PIC controller. And, well, it's also time to try this stuff right here. I ordered some Noctua thermal paste because this stuff is just going to be a lot better than the 510 cheap and cheesy thermal paste that I was using. So we'll get into that. And I'm also going to split the heatsink today, just like I did the other board. So a lot to get into today. So let's get started. First thing I need to do is test the board, right? Let's see where we are chip count wise. So go ahead. Start the tester. Pulling 1.76 amps at 20.2 volts and 0 chips. Okay, so I guess I need to go ahead and take the heatsink off and find out what's going on underneath it. Let's do that. Okay, so as you can see with the board, let me take that off. There we go. So if you notice there, we have a few missing nuts right here. We got a missing nut right there. You get a pointer. Got a missing nut right there. We have a missing nut right here. And I lost a nut right there. So actually 4 nuts came off. So there's the other one there. So we'll get into those and I'll put those back onto the board before I put it all away. But I want to go ahead and, because I know I'm going to do a lot of work on this board. So I'm going to go ahead and put both pieces into the alcohol bath, get them all cleaned up, scrubbed up, and get it right back. All right. So the board's cleaned up mostly. And I did lose another nut while I was going through and scrubbing everything. I'm wearing a glove today, just if you're curious, because I cut my thumb messing with heat sinks yesterday, and well, I don't want to get that alcohol in my thumb. That would hurt quite a bit. Also, if you want to fast forward to another part in the video to see maybe how this works out, there are time codes down below, so you can fast forward and go back if you need to review something. All right, let's get into this. So first things first, let me put it back on the tester. Now on the tester, what I'm going to do is I'm going to see if we can jump this and find out. I suspect we have a problem. Let's see. So that's 60, 50. I suspect we have a problem right around in here. Yeah, that's a new chip. And sadly, I think that's our problem child right in there, because this domain, I saw this domain was going 0. All right, let's get to it. Okay, 0 ASICs found. Grab my test probes or my jump probes. Remember, go to the RO, which on the S17s is the center pin or center of those. And I'm gonna grab the 1.8 volt. We got nothing. I got nothing. Oop, can't do that one. Let's come down here. Let's do this one down here. Okay. So we don't have anything going on. So let's go a step back Let's check our voltages. .75 is not good. Uh-oh. Houston, I see a problem. We lost our main. So that's reading 0.7 volts and it should read 1.8. Yeah, let me come all the way down here. Okay, good news. Okay, so that was working. I'm just measuring up the chips, right? I'm gonna go up the domain until I find out what's going on. Okay. There we go. That's it right there. Okay, this chip's gone bad. Let me get my red marker for that. While we're at it, let's go ahead and check the rest of the domains. Now remember, we're back on an S17 Plus, so the negative side of each domain is over here. The positive is over here for this, like for this domain right here, right? So, all right, so let's just check. Good. Good. Hey, look at that. I got 65. So that chip finally warmed up. And I'll bet now if we check. Okay. I'll bet you if we check the voltage now, I bet we get. We do. Oops. I'm backwards, but it doesn't matter. Yeah. So most likely we have a weak chip right there. Okay. So I don't need to check voltages on all the other domains because we know right where to target. Let me look at that under the microscope real quick. Okay, so that's not such a good thing to see right there. It's when I look under the microscope, and right there I can feel it with my tweezers. There's a ledge. So most likely what happened is because this chip wasn't smooth, it didn't make a good enough heat sink and probably burned the chip up. All right, so that's going to add to my list of things we're going to do today. We're going to go over and just make sure all the chips are nice and smooth. In light of that, I'm going to go ahead and just take that chip off because it's probably bad. Probably bad in a big bad way. All right. All right, let's go ahead and connect it all back up. Let's see how the tester works now. Bingo! 65 chips. Cool. Okay. 65 chips, maybe 65 chips. So we still have some weakness. So, oops, I knocked that off the screen. I'm testing to 20, right? Oops. Pressing a little too hard. 40's good. 50's fine. Okay, so jumpering these isn't going to really tell us much. Let's dive into the voltage and let's measure some voltages. Okay, so when I was watching this, when I was testing earlier, this row right here would go 0 on the chips. So let's see. Okay. Right, should be, the order should be, if I remember right, like 0.8, 1.7, 1.7, and then this one will be 1.7, and then this one should be of nearly 0. 0.1. That's nearly 0. Okay, 0.8, 0.9, somewhere in there, yeah. 0.7, 1.7, 1.7, 0.1. I'm going to keep testing them in order. So that is the clock, the CI, the RO, the RST, and then the BI. Okay. About to run out of time. Okay. Uh-oh, ran out of time. Okay. Get that started again. Okay, 0.9, or 0.8, 0.9, 1.8, 1.7, yep, about right. 1.7, 1.8, yep. Okay, about right. Okay, now this is a fun one. Let me push the thing. So, let's go. We got to do them in order. I want to stay with it. So clock is fine. So clock, 0.8. And then CI, 1.8. And then to measure the RO, got to jump here. Okay, 1.8. Yeah. And then I go back to measure the RST. Yeah, 1.7, 1.8. Yep. And then BI. Okay. So there is a weak chip somewhere in here in this domain. I know that. All right, let's put the temperature test, or the temperature test on here. Yeah. See, that is just funky, funky, funky. Look, 17? What? You see those numbers? I'll zoom in on them for you. Backwards world or something. I don't know. I guarantee you, temperature sense number 2 up here is not. Whew, it's hotter than Hades. It is not 21 degrees Celsius. It might be 121 degrees Celsius, but it sure as heck is not. That one too is hot. These are cool. I don't want to put a bunch of nice fancy grease on there and then have to strip it off. All right, let's check. I'm gonna do a visual inspection on those. Okay, so that is chip 55. Looks okay. Nothing looks bad about it. Look at that pretty brand new shiny chip that I think is bad. That hurts. $20 chip right there, folks. Okay. Could just be a bad solder job. That one's also out of alignment right there. Right here needs to be fixed. It's not in line. All right, let me move over to 15. Check that domain. All right, this domain, or this one, needs to be smoothed out. All right, go back to 46. I'm going to reflow 46 because I think that the issue with this domain going 0 is just a bad alignment on that chip. So we'll do that. Then ask for 45 or 55. Same thing, I want to reflow 55 because it just looks like it may have scooched down too far. Okay, so we'll reflow those two chips right next to each other. All right, since I am reflowing, I will use flux. If I was pulling the chip, I wouldn't use any flux, but I'm not pulling the chip. I'm just going to reflow it. Bit more flux than I wanted. All right. Let's see if we can run the tester on it. It's pretty cool now. See if we're back to 65 chips. Oh, 55. Pretty did it break? It broke right here where I reflowed a chip. So I guess I didn't do that right. All right, let me go look at that one again. Okay, so something just occurred to me. That if you look back at the screen there, it says 55 chips. So 55 means that it got to here, right? Where the temp sensor is. It didn't get to here. So let's investigate 56 under the microscope. I think you'll be surprised what I found. Okay, so that right there, that is chip 55. And if I follow it around, look at that crazy chip. That's 56. It's all kinds of not straight. I really want to scream because I've been looking at this and trying to figure it out. I've even taken 55 and 56 off a couple of times. And then it dawned on me to check the resistors. Particularly, I'm interested. Let me get this a little bit smaller. I'm interested in these three resistors pads right here. So that's R220, R212, and R224. So I go over to my spreadsheet that I made. R220 is supposed to be open. Good. R212. Hey, it's supposed to have a 0 resistor. What's the other one? 224. 224 is supposed to have a 0 resistor. So, dang it. Those two right there, not the top one, but those two right there are supposed to have 0 resistors. Oh. Okay. Let's get those. Let me change over to the microscope only view and let's get some 0 ohm resistors in there. All right, I'm going to place the resistors first. Maybe a little bit too much flux on there. Let's see if I can turn the light down just a little bit. Ooh, you can't see that very good. There we go. How about that? All right. Now let's see if we can keep from blowing these off into some other universe. Airspeed is 50. And temperature is 350. Those are supposed to be 0201s. They sure are big for 0201s. Okay. I'll just touch it up with the solder iron. Okay. So we lost the address. And I bet that I've got it on video when I blew those resistors off the board reflowing. All right, we got 65 chips. That's good. Thank God. Let's run a quick temperature check. Okay, now all the temperatures look normal, right? I can go around there. There's the 48 on temp sense 1, temp sense 2. Now we're at 56. Temp sense 3, 44. Temp sense 4, rising on up, 56. But yeah, so they're all working. They're working the way they're supposed to. This is good. I've already cleaned up the board. Let me stop this. So I've already cleaned up the board, so the chips are smooth, right? So that's good. And I'm gonna put this in an alcohol bath. Yeah, I think I'm gonna put this in an alcohol bath, let it soak, while I go and take this guy and split it. So I'll make my marks where I'm gonna split it, and I'll get this thing split, and then we'll put the new Noctua thermal paste on there. Before I put this thing off in an alcohol bath and let it soak and get it all nice and cleaned and ready for final reassembly, I've got to put the nuts back on. And right now I've got 5 of these little jewels that need to go back on. Okay, look at that. We did create a solder ball right here. When it reflowed. So here's the thing. When you're heating this up, you're actually putting heat into that little square pad on this side, and you're putting heat into the big square pad of this chip over here. Picking a chip up, or picking the board up with the nut so it doesn't go anywhere. Okay, next one. Okay, those should stay on. Put a lot of heat in the board, so let's get the heat out of the board. I'll let it cool while I go split the heatsink. All right, I'm back. And the board is definitely cool. And the heatsink is split, so we're good to go there. Let's go ahead now and run the test. 65, very good. All right, stop that. We'll run a temp test, just make sure our temperatures look good. 43, 39, 45, 43. Good. All right, everybody's in the ballpark where they should be. All right, that's good. All right, let me go get it, put it in an alcohol bath, clean it up. So what I'm going to do, I bought some Noctua NT-H1. I got the NT-H1 versus the H2 because the H2 wasn't available the same day the H1 was. Price is kind of right. So let's talk about this for just a second. Now the Noctua paid twice for 10 grams. I paid twice. I'll put it down here. I paid twice the price of what I did for this guy, and as you can see, this 510 HY 510 is twice the thickness, right? So, but here's what you want to pay attention to: the thermal conductivity is 1.93. Now Noctua doesn't actually give you their thermal conductivity, but some tests that I found indicate it's around 8. So 8 watts versus 1.93. The stuff I'm really looking for right now is Fuji Poly Sarcon SPB30 or SPG30B. It's the pink stuff. It's what I pulled off of the NBTC heat sinks the other day. Trying to find a distributor in the US that'll sell it. I can find it overseas, but they can't ship it to America. Go figure. All right, so as soon as I can find my pliers, I'm gonna take the cap off. We'll put this little, I think it's a 16 gauge lure lock blunt needle. And we're just gonna we're just gonna put a nice little small BB, just like we do with the other. This guy goes on these two. And this guy, we'll put him on last. Is it necessary to split them? I don't know. Probably not. Although, if you know you've got to do a particular work in a particular area, you can pull just that heatsink. So that's nice. All right, there we go. It's all put back together. You can see, maybe you can't see. There you go. You can see where where it's split. So there you go. Let's put it back on the tester and just double check it. .65 ASICs, that's very good. Let's run the temperature test. Good, 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 good. We've got good temps. Now, here's the interesting thing. You can actually flip it over, and as long as you can find the 1.8 voltage, like somewhere in here, you can jumper and test from this side of the board, so you don't even need to take your heat sinks off. If you've got a 0 ASICs thing, you could actually be upside down and kind of figure out which section of the board it is, right? So That's something to keep in the back of your mind. All right. Testing looks good. Let me go get this in a miner and we'll see how it works. Okay, so as the screen shows, 0 ASICs detected. Failed to detect ASIC chips on chain 0. Let's put it back on the bench and let's see what it's doing there. Okay, I've got my voltage set to 21 volts. $65 chips. What gives? Oh, look at that. It just died. Huh. I wonder if there's a... Ah! Okay. We've got a short somewhere in the board or just a bad connection somewhere in the board. Okay, let me see if I can get this in the miner and get it to work. I'll be very gentle. Very gentle. If we can get a hint. Maybe we can get a hint as to what's causing, where the problem is. It's been a long day working on this board. And as you can see, there's something wrong with the board. So for now, I'm going to leave this board as it is. I'm going to let it sit on the bench and I'll think about it. And I'll try a few things. I'll research that error, SOC init. That error seems to be a common error. So I don't know that's going to be a whole lot of help. There's a lot of indications that that's because serial numbers or some number doesn't match between mining boards. But in the case of testing this, it's only I'm putting it in a miner by itself. So that's not the problem. And in fact, this board was working yesterday. So I think the problem is the PIC. Even though I put it on the picket, I checked it. Even though although I didn't record that for you, I did check it. It read okay. I even reprogrammed it. It took the programming. So I don't know. I am going to go grab one of the other boards. I'll use the PIC, pull the binary off of there, and then load that back on here, and I'll see if that makes any difference. But at this point, I guess I'm going to leave you with a cliffhanger. To be continued. Thanks so much for watching. I'm not sure how I'm going to cut this all up, but thank you so much for watching this video. And if you would give me a thumbs up, hit the subscribe button. We are growing. You can also find me, if you look down in the comments, you can find me on Discord. I'm usually in 2 different groups. Those groups are listed down there, as well as my user ID, so you should be able to find me. Ask me a question or give me an idea if if there's something you want to share the super top secret stuff with me. I appreciate it. Thanks so much again for watching, and I'll see you soon.